Good afternoon, everyone. Already we have completed three-phase induction motor. Now today, we are going to start the single-phase induction motor. That is, the induction motor. For the case of three-phase induction motor, we are giving the three-phase AC supply. But for the single-phase induction motor, we will be giving the single-phase AC supply. Now, the single-phase motor, which are designed to operate from a single-phase supply, are manufactured in a large number of types to perform a wide variety of useful services in home, offices, factories, workshop, in business establishment, etc. The thing is, for the three-phase, already we have explained that whenever we need to go for three-phase connection, means there is a large requirement of power. But for the single phase, when the power requirement is less, for the less power requirement, we used to go for the single phase induction motor. Clear? Now the small motors, particularly in the fractional kilowatt sizes, are better known. So the small motors, particularly in the fractional kilowatt sizes, are better known than any other. In fact, most of the new product of the manufacturer of space vehicle, aircraft, business machines, and power tools, etc., have been possible due to of the advances made in the design of fractional kilowatt motors. Since the performance requirement of the various applications differ so widely, the motor manufacturing industry has developed many different types of such motors, each designed to meet specific demands. Now, the single-phase induction motor constructionally same as a polyphase induction motor. There is no such constructional, basically basic motor has no such constructional difference from the squirrel cage rotor type induction motor. Okay. Now, constructionally this motor is more or less similar to the polyphase induction motor, except its stator is provided with a single phase winding. First thing is, the stator is provided with a single phase winding, and a centrifugal switch is used in some more type of motors in order to cut out the winding used only for starting purpose. The another important thing is, the single phase induction motor is not a self-starting motor. Just have a small recap when we are going to use the three-phase induction motor. That three-phase induction motor are the self-starting motor. Whenever we are going to give the three-phase supply, there is a rotating magnetic field, and that rotating magnetic field will be able to start your motor. But for the single-phase induction motor, we are need to use a separate winding for the case for starting of the single phase motor. Now it has distributed stator winding and a squirrel cage rotor. Okay, for the three phase there was a three phase winding, but here we have a distributed stator winding and a squirrel cage rotor. When fed from a single phase supply, its stator winding produces a flux or field which is only alternating. That is one which alternates along one space axis. Okay, it is not synchronously revolving flux as in the case of a two or three stator winding fed from a two or three phase supply. Now, an alternating or pulsating flux acting on a stationary squirrel cage rotor cannot produce rotation. That is why a single phase motor is not self-starting. The main cause that only one rotating or pulsating flux on the stationary, it will not able to produce that amount of pulsating flux. So if that amount of pulsating flux was not able to produce that amount of torque to rotate the motor. However, if a rotor of such a machine is given an initial start by hand or small motor or otherwise in either direction, then immediately a torque arises and the motor accelerates to its final speed. Here, as we used to give a only single phase supply, that's why the single phase supply was not able to generate the torque in a proper direction. That's why you need to give the start, or you need to give a separate torque to produce the proper amount of torque to start the motor. This behavior we can understand from the double field revolving theory. Now, the very important topic we need to understand is the double revolving theory for the case of single phase induction motor. Now, a single phase AC current supplies a main winding that produces a pulsating magnetic. So, whenever we are giving a single phase AC supply, so that AC supply will be able, there will be a positive half and a negative half. So, this positive and negative half will produce a pulsating magnetic field. So, mathematically, the pulsating field could be divided into two fields which are rotating in opposite direction because of the positive half and the negative half. The interaction between the field and the current induced the rotor bars generate opposing torque. So, there will be a problem that whenever there is an interaction between this field and the current induced in the rotor bars generates the opposite torque, that is the one torque for the positive half and the another torque for the negative half. Under these conditions, with only the main field energized, the motor will not start because there will be a positive torque and a negative torque. So the motor will not able to rotate in a proper direction. Under this condition, with only main field energized, the motor will not start. However, if an external torque moves the motor in any direction, the motor will begin to rotate. So that is the condition when we are give a separate supply from the from outside, the motor will start rotating in a single direction. So just have a small idea of the construction of single phase induction motor. As already explained that the construction of single phase induction motor is similar to the three phase squirrel cage induction motor. The rotor used here is same as that used in a three phase squirrel cage induction motor. It is very simple in design and robust in construction, just like as your three phase induction motor. But the rotor is not insulated from the core. That is, the slots on the rotor are either semi-closed type or totally closed type. The rotor windings are perfectly symmetrical and short-circuited with each other. Okay, in that an uniform air gap is there in between the stator and rotor. The single phase motor can be wound for any even number of poles, that is, it may be 4 pole, 6 pole, or 2 pole, depending upon the requirement and the speed, especially. The type of the motor normally have two stator windings in motor that operate with both winding energized. The winding with more turns is known as the main winding and the other winding is known as auxiliary winding. So the main winding will be there and the auxiliary winding will be used to generate your speed, used to generate the starting torque. In case of this motor, synchronous speed equation is Ns equals to 120 F by P, also applicable like a three-phase motor. This is mainly because the poles have opposite magnetic polarity. Clear? So this is all about the introduction of the single phase induction motor and the construction of single phase